Welcome back. Just got caught in my wire here. So we want to find the lateral area of our cone in square units. And so we want to use the surface area formula, not the factor one, but the other one. However, we don't want to use the whole surface area formula because we don't need the base. We just need the lateral area. So that's just going to be pi times the radius times slant. So this is a super easy problem. This one's in your notes. So L here stands for lateral area is equal to, which eventually I think will come up. Well, maybe not the L. There we go. Come on. L is equal, or lateral area is equal to pi times 4 times 9. So that's just 36 pi units squared. That's how easy that one is. All right, 1 minute. That's all it took us. And we really need a minute. All right, so here we want to find the lateral area. All right, but we need to find all of our parts, right? We have to make sure for lateral area, remember it's we need the radius and we need the slant, and we're not given any of those things. Right? We are given the base area. Right? So we have the base area, and now we're going to need to find the radius, and then we can find the slant. And I'm wondering if I erased something when I was working with this one, because I don't have a height up here. So it's not in your notes either, and I had erased this board. So, well, first of all, let's find a height, otherwise we couldn't find the slant. I must have erased it. All right, so we want to, you're going to replace your base area with the formula for area to solve for the radius. Add that to your notes. All right, so we have, therefore, our base area is 16 pi, and we know the area for the circle is pi r squared. So now if we divide both sides by pi, we have that our radius squared is equal to 16. I'm waiting for my numbers to pop up. Any day. If I write them again and they pop up, it's going to be a mess. Let's just assume we need to write them again. Right, so we're going to divide both sides by pi. Like I said, it might be it'd be a mess. A delayed reaction there. All right, so let's divide both sides by pi, and they'll pop up. So radius squared is equal to 16. We'll take the square root of both sides, and that means our radius is going to be 4. So there we have that. I'm going to give us a value for our height because it had to have been in here, and it just has disappeared. Because otherwise, you'd be stuck. You don't have enough information. So let us say that I wish I remember what the height was. Our height is, it could be anything. And actually, I'm not going to make it a perfect square, necessarily. So let's say our height is 12. Let's make the height 12. All right, so now we'll solve for our slant. All right, so our slant height, to find our slant, remember it's going to be radius squared plus height squared equals slant squared. All right, so our radius we found was 4. And we have had to have a height before, so I'm just going to assume, I just decided it would be 12. That must have been the value I accidentally erased. Equals our slant squared. Actually, let me just put s squared. That doesn't need to be in words. All right, so that's 16 plus 144 equals a slant squared. And that's going to be 160. is our slant squared. So now we're going to have to simplify our radical. So 160, right, and right, so that's divisible by 16 and 10, and 16 is 4 and 4, and 10 is 2 and 5. Right, so I could break down the 4 and 4, but I really don't have to. 1 4 comes out, 1 4 goes away, and the 10 is going to stay under the radical. So my slant, I'm going to put it over here. Our slant is going to be equal to 4 square roots of 10. All right, so now we can find our lateral area because now we have all the pieces. So L, remember our lateral area is L is equal to pi times the radius times the slant. So L is pi times 4 times 4 square roots of 10. You just multiply the 4 and 4 together. Number times number, and if there was another radical, radical times radical. So our lateral area is going to be 16 pi square roots of 10. I think it's better to put the pi and the 16 next to one another and then square root of 10. So it doesn't look like anybody else is under the square root other than the 10. All right, so this problem is done. Let's do a few more. All right, so here we have the length of the radius. We want to find the length of the radius of our right cone if the lateral area is 50 units squared. So we're going to use lateral area to find the radius. Make sure you identify your formula first. So add this to your notes. This one, no, this one, is this one in your notes? This one is not in your notes, but you have a lot of space there if you want to put it in your notes. But anyway, and you might want to put this in your notes. So you want to identify your formula first, substitute your variables, and solve for your missing variable. All right, so we need to use lateral area to find the radius because that's what we're given, lateral area, right? Given lateral area. So remembering our formula, lateral area, actually let me just put an L. L is equal to pi times the radius times the slant, right? And we know the slant, right? The slant is 10. So we're going to substitute 50 pi for the L, because that's what our lateral area is. And we'll substitute 10 here for the slant, and then, that's supposed to be parentheses, and then we're left with R, the radius. So now, this is an easy problem. If we just divide, oops, I meant to write 10 pi. If we divide everything by 10 pi, Five's our radius, and we're done. So our radius is equal to 5 units. There's not a unit of measure there. All right, so that wasn't too bad. I think we have maybe 2 more problems, and they're both in your notes. All right, so we want to find the height of the right cone if the surface area is 45 pi units squared and the diameter of the base is 6 units. All right, so you can add in my written steps here. So in step number 1, we need to find the radius. All right, we're given the diameter. So remember that diameter is twice the radius. So that means 6 is 2 times the radius, and so 3 is our radius. So that's the first thing, right? Because we can't find surface area with diameter, we need radius. Second of all, we can't find, we're looking, we want to find the height of the right cone if the surface area is. So we can't find the height from the surface area, but we can find the slant height from the surface area. So we're going to find the slant height using the surface area formula. Let's use both so you can see how to use either formula to find your slant height. So if it says height, that's not a mistake, but you can't go straight to height from the surface area, right? You have to go to slant height. So our using this formula, not factored, right? We're going to plug in the things that we know. First of all, we know the surface area. So let's replace S with 45 pi. is equal to pi, we know the radius, 3 squared plus pi times 3 times s. All right, so now we're going to simplify. 45 pi is equal to, this would be 9 pi plus 3 pi times a slant. That's not a 5, but a slant. I cannot combine 9 pi and 3 pi slant because only the 1 has a variable with it. But I can combine the 45 and the 45 pi and 9 pi. So I can subtract 9 pi from both sides. That gives us 36 pi is equal to 3 times pi times the slant. We'll divide both sides by 3 times pi. All right, so that means that 12 is our slant. All right, so now that we have the slant, we can use Pythagorean theorem to find the height. And we're almost done here with this problem. All right, so we know that radius squared plus height squared equals slant squared. So the radius is 3, so 3 squared plus h squared is equal to 12 squared. And I have very little space to solve this out. Right, so 9 plus h squared equals 144. I'm just going to kind of move this up here. All right, so if I subtract 9 from both sides, h squared is equal to 135. Right, and now we need to take square root of both sides. Let's see if we can simplify 135. So it's divisible by 5. That would go in 2 times, and then 27. You can simplify the 27. That would be 9 and 3, and 3 and 3. So 1 3 comes out, 1 3 goes away. The 15 stays under the radical. So our height is going to be 3 square roots of 15. Right, because that 1 3 did not have a buddy, the 5 does not have a buddy. Right, so here's a multi-step problem looking for something completely different than surface area. Right, so if you need more time, right, then pause the tape so you can take your notes. I'll be checking those notes. And if you have questions, then ask me in class. Right, and the last problem for this lesson, and this one's in your notes, the Department of and actually this is going to be a bridge to our next topic, which is modeling with geometry. So we'll be solving real-world situations involving geometry, and here is a real-world situation. Department of Transportation keeps piles of road salt for snowy days. If they didn't have that road salt, there'd be no way to get the snow. The plows aren't enough. It would be too slippery. The conical shaped piles, so if you pour something, it's going to make, and it's solid, it's going to make a cone shape, are 20 feet high and 30 feet across at the base. During the summer, the piles are covered with tarps to prevent erosion. If you don't cover them with something, all that salt's going to blow away and it's expensive. How many square feet of tarp is needed so that no part of the pile is exposed? So we want to cover it exactly, but we don't want to purchase any more tarp than is necessary. So here's a picture for your notes and some information for you. So sometimes we have to really think about our problem, right? This is 30 feet. All right, so here's the truck. It's dumping the sand. Did you like my picture? It's dumping the salt, and it makes a cone. And that cone is 30 feet across at the base. So if it's 30 feet across, that's the diameter. So the diameter is 30 feet. The radius is going to be half that. So the radius is 15 feet. Now we're wanting to cover it, so we're dealing with surface area. But now let's think, do we need to cover everything? Well, the base is between the ground and more salt. It's covered, right? You don't have to worry about the wind blowing the base away, right? That's on the ground. So that's the lateral area that needs to be covered by the tarp. So you have to, on these modeling problems, you're going to want a picture, and you're going to have to think, use your head and think logically, Do I need to worry about the base? Well, no, I don't. It's on the ground, right? So lateral area is all that needs to be covered by the tarp. So actually, this is a very easy problem once you break it down. Right? So now using my lateral area formula, we can find how much tarp we need. So the lateral area is pi times the radius. We have the radius. That is 15. But do we have the slant? Well, no. Right? We have the height. This is 20 feet high. That's the height, not the slant height. So we have to use Pythagorean theorem to find the slant height. So in your notes, you want to put use Pythag theorem. So you always say, don't just blindly plug in numbers. Make sure you think which values are you given, right? We don't want 30, that's the diameter, and we don't want 20, that's the height. So we want slant height. All right, so it's going to be, I'm not going to write radius squared plus height squared equals slant squared again because I'm running out of space. And we've written that quite a bit. So 15 squared plus 20 squared. Oops, that was supposed to be a square, not an S. Equals S squared. So that is 225 plus 400 equals S squared. And I'm running out of space here. What if I put this over here so I can have more space and go across? All right, so that would be 625. Actually, I could do this too. That gives me a little bit more space. Yeah, I think that'll give me enough space now. So 625 equals our slant squared, and that is a perfect square. The square root of 625 is 25. So S is equal to 25 feet. And now I can actually maybe put this back. So our lateral area is pi times 15 times our slant of 25. And so now all we have to do is multiply. So 10 times 25 is 250. 5 times 25 would be half that. So 250 plus 125 is going to be 375. So our lateral area is 375 pi feet squared. That's exactly how much tarp we need, and no more. And that's the end of this podcast and the end of surface area of cones, right? But we'll see more problems involving surface area, only we're going to be finding the surface area and volume of composite figures, as well as solving some real-world problems like this. Thanks for watching. Bye.